Welcome to Occupations, the podcast, where we discuss what it's like to hold specific jobs. Occupations is brought to you by lotsofmaps.com, where you fulfill your vintage map gifting needs. Visit lotsofmaps.com.
Hello and welcome to Occupations, the podcast. I'm Andy Jaglinzer, and I am here with a very special guest. Although I say that every single week, they're all very special, and this one is incredibly special. Jason Dunion, who is a meteorologist for the University of Miami, as well as the science director of NOAA's Hurricane Field Program out of Florida. But he is joining us on the phone from his home in Connecticut. Welcome, Jason.
Thanks for having me. I appreciate it.
Thanks for being here. Two incredible titles. I know a basic understanding of what it is you do, but let's find out a little bit more. Let's start with the first one, meteorologist for the University of Miami. So what are you doing there?
Yeah, so it's a really interesting position. So I'm a research scientist. So our group specifically studies hurricanes. So it's everything. It's really what makes them tick. It's everything from the track, where are they going to go? What the intensity is going to be, how the structure might change. So we're using data that we collect to try to improve our understanding. And it could be everything from really basic understanding to trying to improve some forecast models that the Hurricane Center might use, or even improving some of the models that we use at NOAA with the European model, and make those as good as they could be. So it's an interesting job that starts with the basics, but we try to have an impact, in the real world and how the forecast can be improved to really help people.
That's very, very interesting. Now, you're at the University of Miami as a research position, but you're not teaching necessarily. Is that correct?
That's right. So it's not a teaching position, though there are some down there that are. But my main connection is we have a cooperative institute that's between Miami and NOAA, which is the National Oceanic and Atmospheric Administration. So that institute is where I'm connected, and it helps me work and kind of bridge that research we do at Miami with a lot of the interesting things that are done at NOAA.
Let's touch on the second half of your title, and that's the science director of NOAA's Hurricane Field Program. So what do you do for that program?
This is a really interesting part of the job. And, I look at it like it's what I do is a nice mix of being in front of the computer, getting together with folks and brainstorming, better understanding storms. So it's a desk job in that aspect. But the field program piece is what gets you out of your office and out into the field. So we actually take our hurricane hunters. We have a couple of different ones at NOAA. There's 2 P3 hurricane hunters. And those, and they're called Miss Piggy and Kermit, actually. They actually have the logos on them. We take those right into the eye of the hurricane. So they fly somewhere between about 5,000 and 10,000 feet right into the core of the storm. Oh, and we also have a high-altitude jet. So this is a converted Gulfstream 4 high-altitude jet, way up at about 45,000 feet. And we're sampling the environment that might be impacting the storm with that aircraft. So we've got, kind of think of these as flying laboratories. So I'm lucky enough to be the science director. I help bring together our plan. What are we going to do? What do we want to study? And how are we going to make it happen when a storm comes? And let's make sure we can take these flying laboratories out to the storm so that we can try to figure out what makes them tick, better understand them.
That's amazing. So these are manned aircrafts, correct?
That's right. So the P3s have about 19 crew members, and it's everything from pilots up front to navigators. I'm a meteorologist on board, so I might be helping coordinate where we're going to go. But I leave the flying and that decision making to the experts. I don't want to be up front doing that. But it allows me to focus on the science and really get things done. And the jet, maybe a bit of a smaller crew. It's maybe 11 or 12 folks. But we might be flying these planes twice a day, so the crews are on these round the clocks that can go for days and days sometimes.
Wow, that's amazing. I don't think of flying and hurricane in the same sentence. It just doesn't make any sense to me, but I understand what you're trying to do. But that's daredevil. I imagine the first person to do it was probably a little loco, but do you feel like it's sort of routine at this point, or is it still harrowing and kind of dangerous and all that? Not that I'm suggesting anybody go fly into a hurricane right now, but...
It's a great question. We've learned a lot since the first flights. There used to be some hurricane hunter missions out in the Western Pacific, so those are actually typhoons. And I actually met one of the old timers. He's passed away, but they used to fly at 500 feet He was taking pictures out of the window. I mean, those were crazier times, I would say. But we learned a lot from those early flights. What are the safer flight levels to be at? What kind of technology can we bring to the table with some of our radars so we can see, exactly what we're getting into? Because it's one of those things where you get focused on the work you're doing. So it is exciting. So you kind of forget, that you're in this environment that, it's not like sitting on your couch. And I'd say even though I've flown many times and into the eye of a hurricane, probably over 50 times, I always appreciate that Mother Nature's in charge. You feel awfully small when you get into those storms. So I think having that appreciation is a good thing, though, and I always carry that with me on all my flights.
I imagine the you can walk around the cabin sign is not necessarily on very often on those flights. Feel free to walk around.
It's not on very often. Exactly. That cabin light's not often, and the drink cart is not coming up and down the aisle on those flights.
Wow, that's amazing. That is totally amazing. Well, let's start at the beginning. Let's find out a little bit about Jason and what drew you to where you're at now. So, Jason, where did you grow up?
I grew up in Connecticut, actually, down in southeastern Connecticut.
Okay. Did you have any early connection to weather at a really young age or no?
I did. It really started getting into my blood pretty early. New England's an interesting place because you can get some really strong snowstorms and blizzards in the wintertime. We get our share of hurricanes too. So I was 8 years old actually living in Connecticut. I had a little weather station, not the fanciest weather station, but to me it seemed pretty cool at the time. And I'm taking all my measurements. And I would actually also record myself. I actually have the tape somewhere around here in my office.
That's awesome.
I would record myself being a forecaster for I think it was the blizzard of 1978 as that storm was coming up the coast. And I think the one that struck me as far as hurricanes was David. That was a long time ago. I was 8 years old for that one too. And it was coming up the East Coast. It had already impacted Florida. And when it came and went right over us, I was not looking out the window. I was actually in my parents' bed, under the blankets, in between the pillows. And I don't even think I looked out the window one time. And lo and behold, now I fly into hurricane. So who knew with that start how it would all end up.
Do your parents go left and right of you when you go on these flights just to bring up old memories?
They do in spirit because they're always wanting to make sure that I'm back okay. They want to keep a good eye on.
That's good. Wow, that's amazing. So even at a really young age of 8 years old, that's really amazing. Was there a person that was there a meteorologist on TV, or was there somebody who visited your school, or somebody that sort of got you into that, or was it just, hey, I discovered the weather every half hour on at the end of the newscast? What was it that actually, or a teacher maybe? I don't know. What you tell me.
Yeah, that's a good question. I think there were a few moments. I think of one, the local meteorologist. I used to always wait for that weather segment to come on, even when I was really young, because I had my weather station. So I wanted to see, how was my weather comparing to theirs.
Sure.
But really impactful was during college. My undergraduate was geography and geology, so not in the hard sciences. But there was a weather class at the very end of my time at the University of New Hampshire, senior year, and a climatology class. And I said to myself, this stuff is really neat. It's interesting. It brings me back to my weather station. And I think I'd like to try to go to graduate school and track this down and see if I can make something of this. So I think those couple of classes at the very end of undergrad kind of lit the fire for me.
Wow. Lesson learned here is keep your eyes open, because you never know when you're going to be impacted by something that could change your life for sure, right?
Yeah, it's a great point. And, for me, I had some experience as a social worker during some of my winter breaks. My sister has severe disabilities. So what I ended up doing was being a social worker during the daytime and taking night classes.
Wow.
So that I could finally, it took about 3 years, I could finally apply to graduate school for atmospheric science, for meteorology. So I really had to want it, right? Those are long days. Social work is awesome. I loved it.
Sure.
But, it takes a lot out of you. It was hard work. I was working with folks with disabilities, helping them live on their own. It was called supported living. But it really, those night classes helped gear me up to be able to finally apply and really kind of chase this thing down that was really, always nagging at me. I wanted to pursue this meteorology.
Right. Well, all right. So let's go back again and bring you back to the 8-year-old boy. You experienced these storms via television and sometimes even experience it yourself with a hurricane coming through. And you've got this little weather station. What's the next step? At what point do you say to yourself, okay, my weather station is good, but it's not great? Or how do I get involved with something a little more advanced with this? Or is it something that you just kind of put in your back pocket and pursued other things temporarily?
Yeah, if I look back, I didn't get a next fancy weather station, but I did still have the bug. I mean, it just didn't go away. Like these recordings of me there was a channel on the local cable that just ran NOAA weather radio, actually. So it's pretty funny that I work with NOAA now and I was pretending to be a NOAA forecaster. But it would just run all the time. And I would have that going probably more than cartoons. But my parents would come down and be like, are you watching the weather channel? That weather, it was even before the weather channel. Are you watching that again? I'm like, yeah, I just want to hear a little bit about, what's going on with this storm that might be coming up. So that for me never went away. And I loved having that channel always at my fingertips. I could turn it on anytime. And I would even talk like the guy. I'd put my deep voice on and pretend I was actually the one who was giving the forecast.
Oh, that's awesome. Well, and the rest of us were watching Bugs Bunny and not learning a thing. So you did very well, I think, by making your choice. So where were your strong suits in school? Were you a math person or an English person, or what was it? Science obviously would be a big one, I would assume.
Yeah, growing up, I was always pretty good at, you made me kind of a broad brush that I was pretty good in a lot of the different subjects. Never off the charts in math and science, but I always put my time in and made it work. And I think, when I wanted to go back to school, my advisor said, you're going to have to take all those classes you avoided, as an undergraduate. But I was always good in those subjects, and I knew that I could do it because I really applied myself when I was younger, whether it was elementary school into high school. I was considered a good student, but not the brainiac. Like I had to work for it.
Sure.
And I think my brain has that natural teacher or social worker. Those are the kind of things I gravitate to. So at least in my field, I'm a little bit off the beaten path as far as, what are some of my strengths as far as bringing something to a job or to a class.
All right, so you get up to high school and you're a junior and you're starting to get the question of what do you want to do? What do you want to pursue? Where are you leaning at that point? Now, you have a sister with disabilities. Was that a major impact on the way you eventually went? But at that point as a junior, what are you thinking? What's your first thought?
It was interesting. I always like to have all my options on the table. It's always how my brain has worked. And even going through high school, I took a lot of different kind of classes. I would take the chemistry class or the physics, but I would take an art class, even though I wasn't great at it.
Sure.
So I wanted to try out a lot of different things. And I think as I got to be a junior or a senior, the guidance counselors would always say, what do you want to do? And I would always say, that's a great question. I don't know. Mm-hmm. I mean, I knew I loved meteorology, but I didn't know what I wanted to do. And I think I wanted to keep my options open as I came into college, knowing that it would probably just work itself out.
Got it. So you attended UNH. So what were you studying at UNH? Social work obviously was one of the things. Was there meteorology? Was that even a major there or no?
Yeah, so when I went to University of New Hampshire, I was undeclared for the first 2 years. I didn't declare until I was a sophomore. So again, I was like taking all of these different classes to try to see, what really was interesting. And it was a great opportunity to be able to do that. And any of the social work that I did was when I was coming home for winter breaks, because I had a lot of connections with people just through my sister, through my family.
Sure.
So a lot of my jobs would be, working as a job coach with someone with disabilities or getting a job similar to that. And my major that I ended up going with was geography with a minor in geology. So they didn't have meteorology.
Huh.
So that track really didn't exist for me.
Got it. And you weren't taking any social work classes at all. It was really mostly just your connections at home and your experience with your sister that drove you towards that.
That's right. It was really the personal experience that got me some of those jobs working in social work. But I did have that bug as well. Like that part was important to me, that social side.
Sure.
So, there was a class called Social Problems. There was a speech disorders class that I took, and I didn't have to. I just wanted to take it to kind of get that experience and get the understanding. So I think I carried that through UNH from my high school days, where I was heading in a direction. I knew that was happening, but I also wanted to experience a lot of different things and maybe get this broad brush from social work kind of side of things, all the way to the harder sciences.
That's important. I mean, I always think, like, you want to be a well-rounded individual, right? When you get older. And so like you were saying, take different classes that you may not be good at, but you want to just sort of experience different things. And I'm sure that's, helped you in what you're doing today in a lot of ways as well. And that doesn't necessarily have to do with meteorology, but all the other things as well.
I totally agree. And I think if I could do it again, I would be undeclared. I think there's a lot of pressure for some students these days going into college, where you have to know what you want to do. And if you do, that's great. But I do like that there should be a little bit of space to explore these different classes, these different sciences, to really get a handle on, what is it that really that gets you going? What lights your fire?
Right. All right. So you're finishing up your college days, and of course the job market is awaiting you. What are your thoughts at that point? You've experienced a whole bunch of different things. You haven't actually done meteorology as a subject, although you've taken some classes and such. What are your thoughts at that point?
I like going back to those days. So just wrapping up my senior year at University of New Hampshire. And, I've got my geography major, my degree with a minor in geology, and I don't know where that's going to take me. And I know I've got a lot of experience in social work. So if I need to get a job and make some money, and I've got my contacts there too. I found coming out that it was a bit hard getting a direction. What exactly did I want to do? And I talked to a few folks. My mom was randomly a friend of someone up in Vermont who was a really well-known meteorologist in my world that I'm in now. And he gave me some great advice when he my mom connected us. And I think what I decided was I wanted to pursue graduate school. And when I started calling some of the programs that I was getting recommendations from this gentleman, they were all saying the same thing. They're like, you're going to have to go back and take some of those classes that you avoided back at the University of New Hampshire. I did take science, but I didn't take all the calculus and all the physics that I needed. There was quite a bit that you need to have. So that's when I kind of made the commitment. I said, I'm going to take these night classes at local universities, and I'm going to get whatever work I can get so I can survive and make it happen.
Yep.
My first job out of college was helping a guy build a house from the base of it all the way up.
Wow.
It was interesting. I was a courier in Boston.
Talk about experiences. I mean, that's, it's just a job to get money, but boy, what a learning experience that must have been too.
It was, and it was, these things that just came to me, and I jumped on them. But at some point, someone knew I was looking for a job in the social work area while I was taking these night classes, and I got a job working with folks with disabilities doing supported living. So rather than having these adults, rather than having them live in a group home or a facility, to help them, support them enough that they can live out on their own in an apartment. And that was really rewarding work. And I did that for about 3 years, a little bit in Connecticut, a little bit in Miami, while I was doing all of these night classes, and kind of with that goal of getting back onto the track of meteorology.
University of Miami was your choice of night classes, but you moved to Miami.
Yeah, that's right. So early on, I was taking some night classes up in Connecticut, Eastern Connecticut State University. And then my wife went to graduate school down in Miami. So our plan was we were going to support each other through graduate school. So she started first, and that brought us to Miami. And I actually did social work in Miami for about 1.5 years. And that's a really interesting place to do social work. I mean, it's such a diverse city.
Yeah.
But I was still down there. I even took night classes to try to move myself toward this graduate program that I wanted to join with meteorology.
So your wife finishes up what she's doing, and now it's your turn? Is that how it went, I assume?
That really was the plan. And at the very end of her graduate program down in Miami, I was trying to just volunteer to do anything at the National Hurricane Center. And they didn't really take volunteers. And I would call and I would talk to the administrative assistant, every maybe it was a couple times a week. I'd say, do you guys have anything? I'll do anything to volunteer. And after a while, she said, you know what? I got into my first graduate school, Texas Tech University out west. And she's like, one of our specialists at the Hurricane Center went to school there. Maybe I could connect you to him. So I actually was a volunteer at the Hurricane Center at the same time that I'm doing these night classes and working as a social worker. But it really opened up a lot of doors and connections for me. So it was a great opportunity for me.
So the lessons there are, don't be afraid of going right to the top, for one thing, and persistence, right?
Persistence really does pay off, and sometimes it's really random. The fact that I got into the school where one of the forecasters at the Hurricane Center happened to go to school, how can you even plan that, right? You've got to have some serendipity along with that.
Wow. Unbelievable. So social work, you're enjoying that kind of work, I'm assuming. It's got to be rewarding in its own right, but you still have this dream of meteorology, of the little boy under the sheets, still pursuing that. And were there tough times when you sort of said, I don't know whether I want to keep going, it's just hard, or it's just been a hard road?
Yeah, I mean, that's a really good question. There were times where there was a lot of juggling going on. And, I remember the number, I was making $21,000 a year doing the social work down in Miami. And it's not a cheap city to live in. And my wife is going to graduate school. Paige is like a 2-year program. So there was this struggle, even just to, I got really good at grocery shopping and adding up down to within $5 how much it was going to cost.
There's the calculus, right?
Exactly. The calculus came shining through, and it was tough, and it was hard when there were long social work days, and then I'd have to go to class for a couple hours, and then on Saturday morning there might have been a physics lab that was like 3 hours. So I had to pace myself because I really had to want it. But I never really gave up on that dream of chasing it. I think it was, am I going to be able to survive, money-wise, and actually be able to stay down here? That was really always on my mind. But we made it work. And, it goes back to that persistence thought that you had. It's, if you really want it and you want to make it happen, you do have to be persistent.
That's great. So in your graduate program, what are you working on there? What really kind of took you by surprise, or what were you learning that sort of really tickled you?
Yeah, I think it was a bit surreal, and I ended up going to University of Wisconsin up in Madison, which is really well known for satellite work. And, they helped develop the first weather satellite way back in 1960. The first satellite image ever taken was April 1st, 1960, so it's almost an April Fool's joke. But that was really exciting to me, and I did not have any kind of support to go up there, so it was going to be expensive. And I remember my godfather said, what schools have you not seen that you're really interested in? Because I didn't have any money to fly up there. And I said, I'd love to see Wisconsin. He's like, all right, I'm going to fly you up. So set up before you make a commitment, because I'd already gotten into Florida State. And when I got up there, one of the professors was asking me, what do I do? A little bit off the beaten path with social work. But he learned that I was volunteering at the Hurricane Center. And he said, we have somebody here in the satellite group who works with a lot of the forecasters at the Hurricane Center. Let me introduce you. So I ended up spending the entire afternoon with that satellite group up at Wisconsin. And a week later, they sent me an offer letter for a full scholarship there.
Whoa.
And that was the turning of the tide. I ended up going there because of an opportunity to go see it. And I always tell students, and my godfather, forever grateful for that ticket that he got me. But I always tell students, when you're interested in a place, in a school, go see it, make the connections. That brings you from being just a resume, just a number, to somebody that they can, they remember. And I think that makes a huge difference. And every student I've worked with, I always encourage them to make that trip before you commit to your school, to your top couple of schools, if at all possible.
Yeah. Well, and obviously you brought something to the table that they liked, for sure, to have done that quickly. That's amazing. So you're working there, or you're doing graduate work there. What kind of stuff are you doing?
It was really interesting. I was funded under this GOES satellite program. So the GOES satellites are the geostationary satellites. They're way up in orbit, like 24,000 miles above the Earth. But once you sit them up in that orbit, they just rotate with the Earth. So they're always looking down at the same spot. So all those newscasts you see at night with the weather segment or the weather channel, a lot of times it's those satellites. So I had some funding to try to detect sea surface temperature from those satellites, which is really interesting. They're packed with all sorts of infrared channels. I was a kid in a candy store. It was like my little weather station on steroids.
Wow.
So, I was really excited. I think the thing that was really hard, though, is I was a student off the beaten path. I was a ex-social worker who was in, geography, geology, not necessarily all the hard science classes that a lot of the folks the kids who were coming into that program were either atmospheric science majors as undergrads. A lot of them were physics majors, math majors. So there were some sharp cookies in there. And I think my confidence was a little bit shaken because the classes were really difficult and the language was even different. I wasn't used to the language of meteorology. They were explaining difficult things with words I didn't even know yet.
Yeah.
So I was shaken. I knew I was going to have to dig in to really make it work.
Well, and it shows that you can, like you said, with a lot of hard work, you can pivot. And even though you're not necessarily the most educated in that particular field, you can still make it work to your advantage in a lot of ways. So that's great.
It is. And I think it's an extra advantage when you're coming into a field where you're a little bit off the beaten path, because you're going to look at things a little bit differently.
Sure.
Than some of the other students. And I think that's a huge advantage. As long as you stick, hang tough and stick with it, I think it can pay dividends in the end.
So how long were you there?
Yeah, so I was up at Wisconsin for 3 years doing my master's. But I got this really small world, another kind of serendipity moment where I was taking my usual classes each semester. But one of the guys from down in Miami at the NOAA's Hurricane Research Division. So this is the division that's like the sister agency to the Hurricane Center.
Okay.
So Hurricane Center, we see them on TV. They do all sorts of the forecasts and coordinating evacuations with FEMA. The other group, this research group at NOAA, their job is to figure out what makes storms tick. Where are they going to track? How strong are they going to get? What kind of changes in their structure are going to happen over time? So I was, just by luck, I was working on these GOES sea surface temperature images, and this scientist was up visiting, and he loves sea surface temperature and hurricanes. He was the guru in the research world of launching probes out of the hurricane hunters to measure sea surface temperature. So we hit it off during his time there, and that actually turned into an internship for me down in Florida.
The temperature of the sea is a major contributor to hurricanes. Am I right?
It is. If you think about hurricanes, it's almost like you're cooking. Like they're looking for very specific ingredients to intensify or weaken really specific things that can affect them. Sea surface temperature, really important. And we typically think of 80 degrees Fahrenheit. That's about 26.5 Celsius. It's kind of the magic number of being warm enough where that starts to be the gasoline that can feed the storms. So especially as we get later into the season, or as storms that are coming across the Atlantic from Africa start running into the bathwater of the Caribbean or down near the Gulf, that can really light things up. And that ingredient alone, it's not the only one, but it's a very important one if you're thinking about how hurricanes might intensify.
Lotsofmaps.com. Vintage, local, national, and world maps for an affordable price. 99% of our maps are $25 or less. Great as gifts. Frame them or put them under glass for your home, vacation home, or as a memory of a special place. Lotsofmaps.com.
You finish up in Wisconsin, and now you've got an internship down in Miami, which is where you but that's certainly where you started your post-college journey.
Yeah, I think it's more like way leads unto way. So the internships that I had down at Hurricane Research Division in Miami were during my last 2 summers at Wisconsin. So I would finish the spring semester and then go down to the Hurricane Research Division for the entire summer. I mean, it was the experience that I got down there was incredible. And I remember my advisor, when I got that connection I made when one of the scientists from Hurricane Research Division was visiting Miami, he said, this is a great opportunity. He's like, do well. And I said, wow, that's a lot of pressure, but I'll do my best. And, I'm still learning meteorology. I know more about social work at this point than the weather. But
right.
I was like, all right, I'm going to make this work. And it worked out really well that first summer internship. I actually flew into my first hurricane during that internship. And it worked out so well, they invited me back that next year, too.
Well, first of all, did you miss the cheese when you left Wisconsin? That must have been a hard decision about leaving cheese or going to pursue meteorology.
There is no shortage of cheese up in Wisconsin. I remember when I first moved there, I ordered Swiss at the deli counter. And I said, I'll take a pound of imported Swiss. And the woman at the counter said, do you mean domestic Swiss? And I said, oh, yeah, of course. I'm in Wisconsin, of course. Yes, domestic Swiss.
Oh, that's funny. Yeah, I'm sure the cheese is fine in Miami, but not quite the same, I'm sure. Let's talk about that first flight into a hurricane. So you're an intern, and they've got you flying in a in a very precarious situation in a hurricane.
That's right. It was a lucky opportunity, and a seat popped up. Like a month before that, there were 2 of us, 2 interns, and the season was a quiet one. It was an El Nino season, and that tends to suppress the hurricanes, so there weren't many that year. And there was a Hurricane Danny, tropical storm actually at the time, and we did a coin flip. So the director flipped a coin, and whoever got it got to go on that flight, and I lost.
Oh,
and I was like, there goes my chance. But I was lucky enough. It was during my Wisconsin back and forth that I was actually staying there until October. Like I was doing an extended internship. So the best hurricane of the season, Hurricane Erica, popped up, and I got to go on that flight because I was now number 1. I'd already lost my coin flip, and it was incredible. And I didn't know what to expect. All I did know was that my old boss at Wisconsin, they called him a 7-bagger. So he did not do well on those flights. He actually filled up 7 air sickness bags on one mission. And I think he's still got the record. And, to this day, he says, I will never take that back, but I'm also never going to go again. He's like, I don't think I could physically do it. So I was nervous. And, this is quite a while ago. So the forecasts have improved quite a bit. The storm, we went up the coast, kind of sampling the environment, and we landed in Bermuda. And the storm was slower than we thought. So they decided to take a down day, and I didn't understand what that meant. And it meant that we had a day off up in Bermuda to wait for the storm to come a little closer so it could be in range. And, I'd never been to Bermuda, this crazy opportunity. I was basically saying in my head at the time, I think this is the gig for me. This is just incredible. And we flew into Erica the next day, and it was a Category 3 hurricane, and experience I'll never forget. And I did well, so that was an extra bonus for me.
Let's talk about turbulence. 7 bags.
Yeah, it's a good question, and every storm kind of has its own personality and own flavor. When I flew into Hurricane Erica, it wasn't that bad. And not that bad, meaning you still need to be seatbelted and it's going to be rough. But we were experiencing, it's the updrafts and downdrafts that will get you. So, some of the updrafts, you feel like the G-forces, you feel like you're just getting crushed into your seat.
Wow.
And then you might catch a downdraft and experience a little bit of zero gravity. So, you might have a pencil sitting in front of you and it might float for a second. And a lot of if you have the up and down very close to each other, it turns into a roller coaster ride, basically. But the difference is you don't necessarily know exactly when that's going to happen, right? So there's a bit of mystery to how it's going to be. But all of that, I think Mother Nature designed a hurricane very interesting. The eye wall, just outside the eye where the strongest winds are, the biggest updrafts and downdrafts, is just miles outside of the calmest part of the storm. And that's what it was like for my first flight. A lot of turbulence. You've got this 5-point seatbelt, it goes around your waist, it goes around your shoulders. And then you pop out into the eye, the sun comes out, almost no winds. I mean, it's like flying on an airline. Wow. Get out of your seat, you can walk around, take a few pictures. But of course, we're flying pretty low, and the top of the storm is maybe 30, 40, 45,000 feet tall. So you got to punch through it. You don't go over the top of it. So if you're in the eye, you do have to get back out again, right? There is this appreciation for, you've got to get back out into the heat of battle.
Are they fighting with I'm going to call it a steering wheel because that's my limited knowledge of flying. I know it's not a steering wheel. Are they fighting with that? Is it that kind of a violent flight?
It's a lot of work flying those Hurricane Hunters. The two P3s that we have, it's an old Navy sub hunter, so it's made to fly low and slow and really take a beating. And it's a 4-engine turboprop, so we'd much rather have propellers, turboprops, than have engines, because engines can take in a lot of water in a hurricane. So it's a team up front. There's a pilot and co-pilot up there, and they're working hard. I mean, sometimes you're not pointing the nose in the direction you want to go. It actually has to be angled a bit because the winds are blowing the plane so hard, you have to kind of compensate.
Sure.
And it's really interesting to watch the flight engineer. So he sits in between the two of them, and his job is to watch the engines. And if you get a big updraft, you may have to crank the engines up to compensate for the fact that you're slowing down. Big downdraft starts pushing you down, you've got to slow the engines. So if you watch some of the video of this triple team of folks working together, it's amazing. I mean, these guys are so in sync and talking to each other, not sitting on the couch talking to each other, but flying with winds that are probably 220 miles per hour up at the flight level, and we're getting bounced around, yet they literally look like they are sitting on the couch, because it's a cool, calm personality that it really takes to do that job up front.
Well, talk about white knuckle driving, right? Man, I can't imagine. So as an intern on a flight like that, do you have any responsibilities, or are you there strictly to learn?
That's a really good question. And it's really up to the lead project scientist how they want your experience to look. They need to know that you're going to do okay, right? Because not everybody, like my boss, my 7-bagger professor, did not do well on that flight. So he was just in survival mode. But I was lucky enough to get to work up some of these we call them drop-ons. They're like the little weather station that I used to have. They cost about $1,000 each, but they have parachutes, and we launch them out of the aircraft, and they track GPS satellites as they fall. But they measure all the things that I used to be able to measure: pressure, temperature, the winds, the humidity, as they fall. And it's radioing all that information back to the planes as we fly. So I was lucky enough to be an observer and just really take it in and appreciate what was happening. But I also got to practice processing some of those drop-ons. They take a little bit of quality control, to get to their final really research quality state. And even got to work our tail Doppler radar. It's kind of like a radar that gives you a CAT scan look at what the storm looks like. So I got to get a sense, which really excited me, right? I didn't want to just be an observer. So I got to do a little bit of both. I got to be a scientist and an intern who was just taking it all in, which is a great combination.
I can only imagine your mind turning. I mean, do you see yourself at that point as, okay, I want to be lead scientist in this mission someday? I mean, are you looking at it in that light, or are you just taking in and saying, wow, I may never do this again?
I was taking it in as this would be a really neat thing to do as the lead project scientist, or even one of the support folks who's helping process all that data.
Sure.
Because I was like, wow, these guys have such a privilege. They get to take, and sometimes we're flying for the Hurricane Center to help the forecast. But a lot of times that research group down in Miami, they get to take this flying laboratory and run their experiments, right? We design all these experiments before the season, and they've been doing that for years. And you're really testing all of your hypotheses and trying to learn more.
Sure.
And so I got the bug just watching everybody interacting, right? The pilots, the flight engineer up front are working hard, but our scientists are in the back taking it all in and saying, hey, we should really, next time we go out, we should kind of come out at this angle of the storm, because I think there's some interesting things that would help our science. So I was really getting the bug even on that first flight.
Okay, so internship complete. What's the next step?
So I go back to Wisconsin and finish up my classes and got my master's. So I felt that was a really great moment because I had worked hard to get that.
Yeah.
I had done my undergraduate, several years earlier, and I had done all these night classes and done social work to try to get to this point. So it was a really cool experience to be able to get to that finish line that I had been working toward for all that time. And I was also lucky enough, those internships got me so many contacts that I was lucky. And I was working as an intern over at the Hurricane Center too when I was down in the summer. One of the scientists at the Hurricane Research Division had some money, some funding, and he brought me down so that I could join that group. So not long after, I helped out the Satellite Center a little bit, but not long after that fall, I went down to Miami and started my time working with that Hurricane Research Division. So that's really, I don't know, would that have happened without all those connections that I got, the internships and the scientists that I got to know so well. So I truly appreciate that as a great fork in the road for me.
Okay, so they bring you aboard. What's your position there, and what are your responsibilities?
So I first come down, and I'm a scientist, and a junior scientist, and I'm working a little bit on some of the internship work that I did. So we would take all these different observations from the hurricane hunters, from satellites, from ships and buoys, and we'd bring it all together to try to analyze and depict and picture what does the surface wind field in the hurricane look like. So we'd actually make a graphic that the Hurricane Center forecasters would use, because they're very interested in how strong is the storm. But they want to know how strong the storm is, not up at our flight level, which is interesting in itself. They want to know what is the wind down at, we call it 10 meters. So 33 feet or so. That's what we consider the surface. Why do we care about that wind? Because it's what people will experience. It's what somebody who's outside is going to experience, or houses and in buildings. It's a really important thing to have a good handle on. So I was lucky enough to do that when I first started working down there. But I also, my boss preserved, and I always do this for my students too, allowed me to preserve a little bit of playing around time too. It wasn't part of my funding. And I started playing around with trying to track Saharan dust coming off of Africa, which ended up being a really interesting science project. But I think if I hadn't had that playing around time and I just had to do all the things that I was officially funded to do, I wouldn't have stumbled on what ended up being a really interesting part of what affects hurricanes. So that was pretty exciting for me.
Can you explain a little further by dumbing it down for the rest of us?
Yeah, so when I was working at the Satellite Center in Wisconsin, somebody used a couple of different infrared channels. So these are channels that, kind of like your infrared TV remote, you can't see that light, but the satellite has a sensor that can see it. And they were able to track dust that was getting kicked off over New Mexico next to a thunderstorm. And I had been flying, I had a couple of flights already, and we would see Saharan dust out over the Atlantic. And I said, I wonder if we can get clever and try to apply similar approaches with these infrared channels to try to track these dust storms, because they seem to be huge. I haven't seen them on the satellites much, but when we're flying across the Atlantic, they seem like they go for hundreds and hundreds of miles. So I developed an algorithm that could track them all the way from Africa. And we started to learn that they're huge. They're the size of the lower 48 states.
Wow.
And they come off the coast of Africa every 3 to 5 days. And they peak in the early summer, so like June to August. And what we learned is they can be hurricane suppressors. And Mother Nature, once again, does a really interesting thing, putting the hurricane nursery over Africa just south of the biggest desert in the world, the Sahara, where these dust storms are coming from. And it's such an important place to look. Over half of our named storms that we get each year, there's 14 on average, are coming from that nursery.
Wow.
And 80 to 85% of the really strong storms, the category 3, 4, 5, those major hurricanes, they're coming from the nursery as well. So understanding how a Saharan dust storm or dust outbreak can affect a hurricane and potentially weaken it started to become a really interesting scientific area for me. And I got a lot of jazzed up when I started to discover that.
Wow. So is there something about the dust itself, like its makeup, that sort of suppresses the storm?
That was the big question. What exactly is happening? And it goes back to, we've got these flying laboratories that now I have access to too. So I wrote an experiment to answer the question you just asked. What can we do? And we can put these little dropsondes out, these little parachuted weather instruments. We can fly over the top of these dust outbreaks that are kind of wrapping into a hurricane, and we can sample them from, say, 10 to 15,000 feet all the way to the ocean surface. It's like my little weather station that I had at 8 years old on, in this case, triple steroids. So I got to write that experiment, and I actually got to lead my first mission as a lead project scientist to try to answer these questions.
Cool.
And what we learned is there's kind of a trifecta. There's a lot of dry air in this dust layer it's about a mile above the ocean when it comes across, so it's not quite at the surface. And its top is at about 18 or 20,000 feet. Super, super dry. And that can really collapse the clouds in a thunderstorm or a hurricane. So that's number one. Very strong winds. There's a jet that hides in these dust storms that sometimes it's 30, 40, 50 miles per hour that can act to kind of rip the storms apart, almost like a skateboarder likes to stand up straight. A hurricane likes to not be tilted. And then the third piece that we started to learn is the dust actually keeps the layer warm. And that, when you have warm air up aloft, it actually stifles clouds. It makes it hard for them to grow. So in this indirect way, the dust itself even can affect the hurricane. So it started to get pretty exciting, and I'll never forget my first lead mission. I mean, I was pretty humbled. I was like, wow, this plane is about to take off to fly my experiment. I mean, what an honor to be able to do this.
We know just by watching the Weather Channel, you can see the storms coming off of Africa, but we certainly didn't, I certainly didn't think that what was happening in Africa really played a major role in this, but clearly it does.
It really is an important player, and it's, you've got the dust storm forming just north of the nursery. It's like the fox next to the hen house. So it's very interesting the way things are set up.
Suppressing a storm. I mean, is man going to eventually be able to do that, do you think, by learning all of these things? And like seeding clouds, can we suppress a storm by getting involved? Yeah,
and that gets to be a very interesting area with a lot of questions that start to come up. I think it's even extra interesting that Mother Nature has made these, we call it the Saharan air layer, these Saharan dust outbreaks are kind of like a natural suppressant that just Mother Nature has. But there's also a lot of work that people have tried to do. And whether, like you said, it's cloud seeding, where I know there have been a few stadium events, I think it was in South America, where they seeded clouds to kind of rain these clouds out so that there wouldn't be rain in the area. And what's really interesting is the two P3 hurricane hunters. So that's Kermit and Miss Piggy. We got those back in the mid-'70s. And the reason that they were purchased was to look at cloud seeding and could we affect hurricanes in a way to weaken them, say, before they made landfall. And there were lots of flights. And the takeaway in the end was there were a few cases where there was maybe an up and down in the storm intensity. But what we learned later was Mother Nature has this, we call them eye wall replacement cycles, where the inner core of the storm actually starts to fade. And then a new eye wall, this ring of very strong wind, starts to form outside of it. And it kind of contracts and it replaces the old one. And it's a natural phenomenon of hurricanes. So we started, really, when we look back on it, there's really not a lot of convincing evidence that we were able to make any detectable change in the hurricane intensity. But it's very interesting. And it has a lot of ethical questions too. Like, what if the storm weakens for a while, but it suddenly starts to really intensify and it affects a different country?
Right.
It's a part of the meteorology of hurricanes that I think we have to be very cautious about.
Mm-hmm. So you were junior scientist at that point. You get your own mission. You get to go do some experimentation with dust storms and such. That's amazing. At what point do they say, okay, Jason's a real player here. We need to promote this guy up to a higher position and have him do some different things?
Yeah, I think the important thing when you're a group like I am, I think of it as like a meteorological think tank. I mean, that's what we do, and it's only hurricanes that we're focusing on. But the senior scientists, they're grooming you in the background, and you don't even know it. You have your first hurricane flight, and they're watching how do you do in this extreme environment, and what kind of decision making do you do under these pretty intense conditions, right? Everybody's not going to react the same. So there's this slow progression, like, this could be somebody that's going to be really good in our group. And can they bring together all their ideas into these hypotheses and put it down on paper and make an experiment? And that was something I was lucky enough to get to do with those Saharan dust outbreaks. So that progression started to slowly take place. And I really liked my time in the field and in the plains. So when I was still pretty young, I got to be field program director for one of the years that I was doing some of the Saharan dust outbreak flying. And that was a lot of fun. That gave me a lot of experience. And I think, when you think of a scientist, maybe you tend to think, we tend to be a little bit geeky. Maybe my strength coming from social work is I'm pretty good at working with people. And that's such an important piece of being out in the field and leading a field program. And, there are plenty of people who do it better than I do, but I have a pretty good knack for it because I'm off the beaten path. And I think it's a good thing to be able to, like we talked about, just because you do have different experiences and strengths, it doesn't mean you can't fit in really well to a group like scientists who are doing the work that they do. And I think that those strengths of social work have helped me over the years do a lot of leadership roles because working with people is so important, especially when you leave the office and get out to the field, whether we head to Barbados or St. Croix or the Cabo Verde Islands off of Africa.
Going back to the science, is there a prep team working on future experiments, and is there a post-test team that will then take the information that you gather from the storm and run with it?
Yeah, good question. And we try to support and foster from start to finish, right? Start is your very first ideas, all the way to publishing your findings or improving the models. And where it really starts is the brainstorms and talking to each other about ideas and how it might turn into an experiment that you could take those flying laboratories, the P3s or the G4, out into the field. And a lot of times it might be a meeting where we're deliberately talking about ideas. Sometimes it's a backhaul conversation that came out of nowhere. And those are, to me, they're just as important because I've had those, like these epiphanies come from a random moment. But it's bringing that together and saying, all right, well, what's our hypothesis? Our hypothesis is that the dust storm is probably going to weaken or suppress these seedling disturbances that come off of Africa. So let's write something up. And I'm going to work with the field program leads, and I'm one of them this year. I'm going to work with them to come up with a plan that we can do, right? Because they know better what the plane's capabilities are. If I'm a young scientist, my strength is I know what my hypothesis is and what I might want to go after, what What questions do I want to go after? So we get that into the plan. We don't want to go out into the field every year, every summer without a plan. We want to have an idea of what we're doing. So we put a very intricate plan together with lots of experiments and make it happen. And the field program leads make it happen. They work with the Aircraft Operations Center to do exactly what the scientist needs to get the data that they need. And then there's a whole team afterwards that pores over that data and tries to come up with some interesting things, takes those results to conferences, writes papers on those results. But it's always so fascinating to watch the beginning to the end, I mean, what it takes to make it happen. And I think we've gotten really good at tying it all together so that scientists really can get the biggest bang for their buck.
If it's your idea, are they tapping into your brain even further with that? Or is it okay, Jason's done his part, we need to go on and do our part in a different way?
It's always interesting to me, the data that you collect and, what do you consider yours as far as the ideas? And I think scientists in my world are very respectful of each other that way.
Sure.
Somebody's ideas are so important. And I think when it first starts, I might come up with the idea like, let's drop these little weather stations into these dust outbreaks. 'Cause I wonder if they're dry. Boy, are they dry. They're like half the moisture that you'd usually see in the tropics, all the way to the Caribbean and the Gulf. So there's something really there, which is really interesting. And the team, we wrote a paper and I was the lead on that because I was the team lead. But a couple of other scientists on the team are like, I was also talking to so-and-so about this part of the flight. And I might say, I think you should run with that and lead that. And that's part, I think, of being a good scientist is that you don't want to sit on all of your data and all of your ideas.
No.
You do want to take ownership on some of it, but you want to share it because when you do, really good things happen because other people think of things that you might not even had on your radar, but suddenly it makes a lot of sense. You come up with your best ideas, put it in your experiment before the season, and there's a whole continuum. Even during the season, some of the other scientists, we work with university scientists, Office of Naval Research, NASA, NCAR, National Center for Atmospheric Research out in Colorado. So they may say, that mission was great. If we could do this next time, we think we could get even more out of this. And sometimes we'll make those improvements right on the fly. If it's a big change, we might make it the next season. We might actually revamp the experiment to have a slightly different angle. But I think if you need to evolve it if you want to get the most out of it, right? We're not flying all the time. And it is a privilege to be able to do every single flight. So we want to get the most out of it. And if we can fly a few different experiments on one mission, that's even better.
Do you ever fly when there isn't a hurricane to get experiments done on non-weather events?
There are a lot of groups in NOAA who look at, and they use the hurricane hunters in the off season to look at things like atmospheric rivers, these moisture plumes that come from Hawaii and can really kick off big rain events over California, or atmospheric chemistry, looking at pollution over cities. So there's a lot that happens all year looking at all sorts of different disciplines in science. But our piece is really happening in the hurricane season. Typically July to maybe early November is when we tend to fly a lot. But even then, sometimes we're not flying a hurricane. Just after Hurricane Erin moved through, we had a deployment from one of the Air Force hurricane hunters of all these wave buoys just ahead of the storm. And then the storm rolled right over those buoys. And then we came with our P3 hurricane hunter, I think it was Miss Piggy actually, and overflew that same array where all those instruments were. We put our own instruments down too. And the goal was not to fly in the storm, but to look and better understand what's the ocean response when a hurricane rolls over a part of the ocean. Because these storms, they roil up the cold water from below. It can really change things for several days, even could be a couple of weeks. So it's really important to understand. So sometimes we find ourselves flying non-hurricanes, but maybe it's before the hurricane comes or just after it's passed by, at least for our group.
Do you ever do testing that is coordinated with, let's say, a ship or someone on land where you literally have to coordinate in the storm to get certain readings, or is it like you just go do your thing, the boat will go do its thing, the land people will do their thing, and then you compare notes afterwards? Or are there experiments when you can literally need to collaborate physically when it's happening?
Yeah, and sometimes you're just going to have collaboration as serendipity, and like you said, it could be a landfall team who's taking measurements at landfall on the ground.
Mm-hmm.
It could be a ship. It could be another hurricane plane. NASA has some planes as well. And those are great if you can have the serendipity, but I think you can take it to a next level if you can have coordination and talk ahead of time to get the biggest bang out of for your buck. And we do that. We'll coordinate with NASA days ahead of time. Like we bring them into our planning so that we can design flight patterns that get better coverage of the storm. Or we'll work with a lot of the universities who set up towers where they've got my little weather instrument, but again on steroids. They set these towers up ahead of the landfall, or even have ground-based radars. So we'll coordinate with them before landfall to come up, and they're part of our landfall mission. They're part of the scientific team that was running the experiment. So we'll take measurements along the coast, knowing exactly where they are. And we have people on the ground, some of our scientists, who have a NASA satellite, a NASA tracker, so we can see where all the planes are. We can put up where all the ground teams are. We can see ships and buoys. So in real time, we can really get a better sense for what's happening out there and what can we do to just squeeze a little bit more out of this.
All right. I have a question that you're going to say is the toughest question of all my questions that I will ask. What is your day-to-day like?
That's a good question. I love my day-to-day. And it depends on the time of year. So during the wintertime, I might be going to a conference and presenting some new results that I have. And I want to, use that opportunity. And being a social worker, I like to have all those interactions. It's a great opportunity to get feedback and do backhaul discussions. I might be writing a paper. I've got one going right now that I want to submit to a journal to get published. And that's kind of how you get your work out there. I might be giving a talk to a school that's invited me, to give a hurricane talk during the wintertime. And then as we get into the springtime, we're starting to plan, what do we want our field program plan, or all of our experiments? How do we want this to look, and how do we bring it all together? And in the summer, you might have all of those things going. I gave a school talk in July. I was lucky there was no storm out there. But I also can't plan a lot of vacations during the summer because there could be a storm anytime, right? It's hard to know exactly when I'm going to have to head out to the field or maybe support from the ground. So I'd say the summertime is it's back to me being undeclared at University of New Hampshire. It's my most wide open time. Anything could happen. I could be given a kindergarten talk, or it could be flying through a Category 5 hurricane.
Do you ever do any coordinated testing with other nations?
There's a long history of the NOAA hurricane hunters collaborating with really countries all over the world, right? We call them hurricanes. Down in Australia, they're cyclones, typhoons out in the Pacific. Everybody's got, most of the world has these or experiences them. So our planes have actually flown all over the world. It's a big effort to have a field experiment out, say, in Australia or somewhere else, especially when we were supporting the Hurricane Center during the summer. So we don't tend to go to other countries during the summer because it takes a long time to get the planes, from halfway across the world. But there have been great opportunities to, our planes have flown cyclones and typhoons, and we've worked with folks at Cabo Verde, these little islands off of Africa, their weather service, to look at these tropical disturbances and Saharan dust storms just as they're coming off the coast. And those islands are like 400 miles off the coast. We work with Barbados with their weather service to try to get better observations and use some of their understanding kind of that local area. So there's lots of collaborations that go on, and some of the bigger field campaigns tend to happen in our off season in the Atlantic. But there's typhoons in our off season. They happen in our winter time. So there's always a chance to do collaborations.
Great. And I assume you compare notes with other organizations as well?
We do. The tropical cyclone communities pretty small. So, we have meetings every year, every 2 years, that bring some of the experts on tropical cyclones, whether it's hurricanes, typhoons, bring us all together to talk and exchange notes. And of course, we're doing it all the time, right, with today's technology, but actually being together in the same room at the same conferences, that just takes it to a new level. So there is a lot of exchanging of information, which I think is awesome. And it's an opportunity. I always tell students, do not miss these conferences, because this is how you network and this is how you learn.
Yep. Do you have any advice for somebody who might want to get into, well, let's just say the field of meteorology in general, or even something more specific in your case?
Yeah, if I think of the younger kids who might be in elementary school, middle school, high school, if something like meteorology, some programs call it atmospheric science, if that's an interest to you, pay attention to those science courses, like could be chemistry, could be physics or calculus. And try not to shy away from them if you want to keep that door open. You can always go back. That's another piece of my advice, is it's never too late to go back. But pay attention to those hard sciences, those STEM classes, because those can go a long way if you do want to kind of head in that direction for your career. And anybody who's older, maybe at the end of high school, maybe into college, it is not exactly on that track. I would say do what you want to do. Chase after that dream that you might have, and make contacts, right? Face to face. If there's a school that you're really interested in, make sure you take a trip there and meet some of those professors. Or if you want to just ask some questions to somebody who's an expert in that field, get that networking going. I think the networking is great. It's very obvious sometimes. You'll see, oh, I made all these contacts, but there are all these subtle contacts in networking that happens as well that you don't even know is going on. You find out later. Like so-and-so talked to so-and-so, and you got an opportunity that you never would have had. So I think the in-person that really makes you stand out, that goes such a long way in any field, but definitely in meteorology, is always have that on your radar and make that a high priority.
Jason Dunion, thank you so much for joining us on Occupations and really schooling us on hurricanes and your path to them. Thank you.
Thanks for having me.
All right, join us again for another episode of Occupations, the podcast, coming up soon.
Occupations has been brought to you by lotsofmaps.com. Please follow Occupations, the podcast on Facebook, Twitter, and Instagram to find information about our next episode or to see what past episodes are available.